In today's video, we're going to talk about circuit construction techniques and some of the techniques and methods that I've used to build a lot of the circuits that you've seen in some of my videos and maybe some that you haven't seen. And we're certainly not going to cover every possible way that you could build your own prototype and breadboard circuits, but we'll at least cover some of the ones that I've used with success in the past and still use very often here on my bench. Probably the most common are these Pushin protoboards. They just have spring clips essentially behind each of the rows of connectors here to allow you to push components in and wire things up. You don't have to commit anything. It's very easy to make modifications and experiment. And these work really well as long as you're dealing with circuits that are operating at frequencies below a few megahertz, or circuits that are not particularly sensitive or fast or low noise and things like that. But for the most part, they work pretty well. And you should have a couple of these laying around if you're doing any kind of circuit building at all. They're really quite handy. But certainly nothing very high performance about them. But they do work well for just throwing some circuit ideas together. Some of the other things that I'll do are more point-to-point type wiring. Using a board like this one here is really nothing more than a plated hole, through board, a pegboard, if you will, with some plated through holes on both sides. And the idea with this is that you would, mount your components on them, and then just literally point-to-point wire them in the back. And if we see if I can get the lighting on this well, you can kind of see that, just got kind of hard wires. In fact, it's really just the component leads themselves that I've got dressing around, and they're stiff enough that you can run them point to point and dress them so that they don't short against each other. And for building one-off circuits, it actually works pretty well. This is what one of those boards looks like without anything populated on it. Just a set of plated through holes, and it makes it really handy for soldering. Another one of the circuits that I did that you've seen a video on was this one here. This was the D104 microphone preamp with the active bass and treble control circuit. All the components on this side, and then on this side we see the same thing, just literally soldered, wired together in a very direct way. And again, you can, with solid wire, you can dress these leads so that nothing shorts out and everything works fine. And this is pretty good for, again, circuits that aren't going to be really high speed because there's no ground plane or anything like that on them, but the technique does work well. Kind of building on that, well, I'll do one more I think on that theme, and this builds on it a little bit. This one is actually the circuit that I used to put the composite video onto the oscilloscope screen. Analog video in, XYZ out, and my little trailer video and some of the other ones you've seen where I put video on the scope screen was done with this circuit. Now this was also kind of point-to-point wired. You can see all the components on this side of the breadboard, but you also see some buses here. This is a little bit of a different board. I think this one was made by Vector. And you can see the wiring in the back here. There's a couple more features to it. Instead of just being a plated through hole, there are some holes that are kind of bussed together so that soldering a component into two of these adjacent leads will connect them together automatically. And there's also a couple of buses that you can tie into to use for power supplies and grounds and things like that, and that's what I've done with this one. These are really handy boards. I've got a couple of these that I've had around here for years, so I built this circuit using one of them. Let me show you what that board looks like unpopulated. So here's one of the boards from Vector. I think it's a Vector 4610. I wonder if you search around you might be able to still find these. But you can see the LAN pattern is really, this one happens to have 3 contacts and then a bus, and then 3 contacts and a bus. And this is handy if you stick like dip components through here. You've got additional 2 more holes that you can use to connect things up. The other side is just a blank board. And so really handy to give you a couple of more tie points for connecting boards up. There are other variations of this available. In fact, there are a number of folks, I think a company called BusBoards makes a set of boards that mimic the pattern that you have on these solderless breadboards. so that if you built up a circuit on here and you like the way it looks and you optimized it, you can buy a board that has the same connections on it, so you could build the circuit essentially exactly the same way as you have on the breadboard right on these boards. And that's kind of handy. Probably a little bit better performance than you'd get with the point-to-point wired like I showed earlier, but certainly not as good as building something on a copper clad or designing your own printed circuit board. But that's another idea, and it's worked pretty well for me. Another technique that I use is simply direct point-to-point wiring. Here's an old project I built probably 20 years ago. It's just a simple little digital countdown timer using all discrete logic and a little timer chip and some 7-segment LED displays. This is going back quite a ways. But this one you can see was all point-to-point wired. I actually used wire wrap wire and just did a point-to-point solder job, from all the different wiring locations, to the other wiring locations. And this, for low-speed circuits, this works fine. It's just another way to go. And looks a lot more complicated than it is, but if you wire things up in a kind of a logical way, it's not too bad to follow. But that's just one other way that we used to do it. Not so popular nowadays, but it's just another technique that I've used pretty successfully in the past. Another technique that I've used, I simply call it sky wiring, which just wiring components through the air. As you can see with this one here, this was a little fixture I built up to kind of show some principles of detecting and measuring RF signals on an oscilloscope. Did a video on that a while back. But here you're literally just wiring, with the component leads from point to point, and just soldering down to the ground plane here, using the component leads themselves to make all the connections. And I call this kind of sky wire technique. And again, works pretty well, allows you to keep the component leads short, wire things the way you'd like. Here's another example of a fixture that I used for a couple of different things. This one I think is a fixture I used to show how to measure our resistors and capacitors and inductors using an oscilloscope and a function generator or a pulse generator. And just got some sockets wired in here. Oftentimes I will solder boards together like I did here, using solder almost like a weld, to connect boards together like is shown here. And again, so it's just a combination of putting boards together and sky wiring components in there. But this kind of techniques works really well for throwing things together quickly to make nice robust test fixtures. Taking that sky wire technique one step further is this little bridge circuit that I used as a demo of matching an HF antenna with an oscilloscope. And this uses kind of that sky wiring technique of wiring components just directly to where they have to go. But also if you look carefully, you can see there's another little bit of circuit board kind of glued down here, another little bit of circuit board glued down here. There's basically just segments of this little strip line circuit board that I have. Just cut them off and glued them down, and that just created a couple of isolated islands to put components on. So rather than etching a board, just a way of creating these isolated islands. Now there's a number of companies that make various patterns, and we'll talk about that in a moment, that you can use on your boards like this. But just for creating those little islands, you can make them yourself a couple of different ways. So let me show you what I'm talking about. One way to make those islands is to use a punch like this. I just got this at the local tool store, and you can see it just has a punch with a jaw that opens up here, the kind of a punch and die, if you will, almost. And there are different size, different diameters you can put in here, and you can actually punch holes in a circuit board and use the holes that you punch out as little islands. Here's an example. Here's a board that I've punched some holes out of, and here's the little islands that are left. And what you can do then is take these little islands and glue them down to a board using like super glue, and now you've got a little isolated island on the board that you can use to solder components to that won't be connected to ground. I've used some variations of those little isolated islands on a couple of these projects. Here's the very fast edge pulse generator that I've used in like a TDR video and things like that, and You can see on this one that there's a little circuit board kind of mounted on top of this other one, and it's got a pre-etched pattern for this 16-pin dip or 14-pin dip that I've got on here. And this one was made by a company called Solder Mount Systems out of Germany, and I'm not sure they're still in business. I bought these years ago from a distributor called RDI Wainwright in Pennsylvania. But there are other companies that make similar types of little daughter boards or little snippets that you can put on your circuit boards. One of the examples is a company called QRPme. He's got a couple of examples for 8-pin dips and various SOIC patterns and 16 and 14-pin dips, as well as even just isolated LAN patterns. And these are all kind of scored, so you can just literally break them apart and use just the pieces that you want. Okay, glue them down to the board and create your isolated LANs. These are a lot nicer looking than the little islands that I showed that I punched out with my little punch tool, but they certainly serve the same purpose, and certainly a lot neater looking and nicer looking than the self-punched out things. Now, let me show you a really nice example of some construction using these things. You may want to check out this website. It's by a fellow ham. His call sign is AA7EE, and he's done some remarkable work and just almost artistic with with these little QRPme LANs. You can kind of see in this example here, his website has got all kinds of descriptions and videos and things like that of some of the circuits that he's built, and many times with this. And this guy, he's an artist, man. He's got some beautiful work with these little LANs here. Can really make some very beautiful circuits with this. So I'll put a link to this website here and this blog in the show notes here, so you can kind of check it out yourself and see what kind of work he's done with this. But absolutely phenomenal. And this is the QRPme website. It's just QRPme.com. Okay, and he's got all kinds of kits and things like that. Those little circuit board parts that I talked about, he's got them on here. Plus he has all kinds of radio kits if you scroll down here. And one of the claims to fame of this guy here, Rex, is that most of his kits are supplied in these little tuna tins. Okay, so they're actually, when you get them, they're sealed up like an actual can of tuna fish. Okay, there are radio kits and things like that that are available. This one, called the Manhattan Chowder, is basically the whole set, or a whole set of these little pads that I showed you earlier. And because that style of construction is called Manhattan style construction, because it kind of looks like a bunch of buildings standing up like Manhattan in New York City. So this Manhattan clam chowder, or Manhattan chowder I should say, is a whole collection of those little bits and pieces. And you'd find them, you know, on this website here, QRPme.com. So highly recommended. My mixer board here was another example of using one of these little daughter boards to mount a dip component, and then the rest of this stuff is just kind of sky wired in here. Just another example. This circuit worked, parts of the circuit actually worked well up into VHF frequency range, so you certainly can do a lot of nice RF work by building right on top of a copper clad board. Another variation of the sky wiring is something called a dead bug construction, and that's where a lot of times you take a leaded component like this and you glue it down with its legs kind of sticking up in the air, very much like a dead bug laying on the circuit board, hence the name. And in this case I actually used some surface mount components. Okay, and you can see the surface mount components here between the leads and going directly to the ground plane. We've also got a little isolated pad right here. So this is using a combination of some of the dead bug and some of the Manhattan style type of extra little circuit board pieces and things like that, but anything that will kind of work. Here's another example of kind of a dead bug type of circuit. I've got an integrated circuit package in here, and if I can get this thing to focus, you can see some other surface mount components in here, and some isolated areas that I cut with a razor knife. And that brings up kind of another construction technique. If you just need to isolate a couple of small areas on a board, like I did here for this the fixture I built for showing what a pin diode does and how it works. You can see some isolated areas, and these weren't etched. I literally just scored the board here with an X-Acto knife and just peeled the copper off the board to create a couple of isolated areas for my RF path going through the pin diode here, and then just kind of Manhattan style glued on or soldered down. There's other components that went in here, and that's how we made this little fixture here. It's just literally using an X-Acto knife and a pair of needle nose pliers and a real fine bladed screwdriver to peel up copper where we didn't want it. So another technique that works well if you don't have a lot of copper to remove. You certainly could score and remove copper using a cutting wheel and a Dremel tool. That's another way to go around it. So that's certainly another technique. I've also seen a couple of articles where folks have taken and actually made a crosshatch pattern on a circuit board using a Dremel tool with a cutoff wheel in a fixture to create these rows and columns, and basically creates a number of just isolated islands that you can use as solder points. So that's another technique. Which brings me to another really cool island creating technique. Well, we've talked about creating isolated areas on a board by scoring them with an X-Acto knife and peeling copper away. Another way is to use an island cutter. This little tool I've got chucked up in the drill press here is just that. It's just a diamond impregnated kind of a hollow tube that can create an isolated ring on a circuit board by cutting copper away in a ring. Let me show you what that looks like. Pardon the noise as we fire up the drill press here. And we just bring this down. Let's create another one here. And we take a look at that. We can kind of see I've got a nice little area kind of hogged out here. I went a little deep with this first one. Let's see if I can get the light on this just right. I don't want it to glare. That's better. So you can actually see just an isolated area. So instead of gluing down those little pads, you can actually just create these little islands on your board as isolated solder tie points. And of course, this will take a little more pre-planning, so you know you place these where you want them, or you could put an array in there. And so there's a nice little technique. And this is illustrated pretty well in a couple places online too. Let me show you that. That cutter I was just using is also sold by QRPme, sold as this thing called an island cutter. And this is the website for that. You go to QRPme, you'll find it. But it just comes in this little tin. And it's got a couple of other printed circuit board pieces and stuff thrown in there for good measure. But that's $30 for that. Now, if you like that idea, and you don't want to spend $30 on the island cutter, there's also was a nice article on Hackaday not too long ago. I guess this was back, about a year and a half ago, July 2012, that shows just cutting those islands into copper just like I did here. And this one shows a homemade tool that was made by a fellow YouTuber, AndyDaviesByTheSea. And actually, if you scroll down here, there's a link down here that if we click on this link, that'll bring you to the video that shows how he actually ground a 1/4-inch drill bit into a pattern that would create these islands. So that works very well as well. So that's also a very nice technique. For some of these circuits, you can even do the sky wiring even with surface mount components like I did for this one here, which was a little 10 dB attenuator I built for the video I did on RF and microwave attenuators. So anyway, I hope I gave you a little bit of a feel for different types of techniques for building circuits, from breadboards, for low speed stuff. And if you're getting into more high performance circuits, maybe doing a bit more of close direct wiring and more permanent wiring for things. When you get up in higher speeds, it's really advantageous to build circuits on top of a piece of copper clad, because that can be your ground plane, and can make some really high speed circuits doing that. Got a number of techniques here. A lot of these circuits worked well up into a couple hundred megahertz for various things that I was working on at the time. So there's lots of different techniques, and certainly this was not an exhaustive look at all of them. But there's a lot of folks out there like QRPme and some other folks that make some really nice prototyping aids, you know, like these little boards like this. There's another company called makes SchmartBoard, and it's SCHMART board, that makes similar types of breakout boards and things like that to make it easy to adapt different types of packages to prototyping use. So lots of other techniques and stuff that are out there. So again, I hope you enjoyed this. If you have any questions about any of these little techniques that I showed you, be sure to let me know. And thanks again for watching.